Hello everybody, welcome to Testing Stage 2022. My name is Mykola Panasiuk. I'm QA Tech Lead at PMetrium Tech Company. Today we are going to speak about PMetrium Native, a brand new tool, and let's measure the performance of native apps. Before we continue, let me say a few words about myself. I have been in IT sphere for almost 9 years. 5 years in automation, and my main responsibilities are automation, non-functional testing, development of testing tools and frameworks. On the right side of the slide, you can see QR code for my LinkedIn profile. In case you will have some questions after the you can contact me or write down to the chat in Slack for this conference. So let's speak about why does the performance of native applications matter? What kind of tools do we already have on the market? What is PMetrium Native and why do we need it at all? Live demo of PMetrium Native. After that, we are going to answer the question, what is under the hood? And where to move next with our instrument. A bit of a spoiler for you, PMetrium Native as an open source, and Q&A session after the presentation in case you will have some questions. So the first part of the presentation, why does the performance of native apps matter? To answer that question, we really need to understand and to know what is performance testing of native applications itself. In my opinion, it's a set of activities to evaluate the user experience while using the native application and their impact on the system. Usually, the results of such testing are represented as a set of metrics of CPU, RAM, battery usage, responsiveness. It can be also some network metrics as well, and etc. So, what does impact on performance of native application? At least we can highlight four main factors. The first one is device hardware and operation system on the device. Nowadays we have a lot of different versions of Android, iOS platform, different CPU manufacturers as well as other components of the system, some RAM memory, storage, some chips for cellular network, for Wi-Fi, Bluetooth, and so on. And these impact on the performance as well. Second factor is native application architecture. How did the native application has been written, the efficiency of the code, the design of the code, and so on. Third factor is server-side and API response communication, in other words. Nowadays, it's hard to imagine an application without some communication with the backend, with some additional logic for tracking your user, for storing some data, for making some analysis, for better logic, for some suggestions to your user, in other words, to increase experience and to earn money at the end. And the last key factor in our list is network speed. Following from the previous point about API communication, we need to have as fast network as possible, because communication from server to device and vice versa need to be quite efficient in a real time. So knowing this, we can truly, even on a high level, to answer the question, why does the performance of native apps matter? It matters because of impact on the user experience. From this impact depends lose your customers or not. In case you will lose your customers, another result will be you may lose your money, potential earning. Also, it has some impact on the system, some battery usage, and sometimes system glitches, and other behavior as well, bad behavior, I mean. Okay, continue. What kind of tools do we already have on the market? Because originally we started from some investigation of what kind of tools do we have. The first was Spectre. We consider this instrument, and on the screen you can see some live demo of the dashboard of this instrument, and it's quite good tool for measuring performance in a real time. One more time highlight, in a real time, for Android and iOS devices. It has some pros and cons at the same time. Let's start from pros. It's easy to start to work with this instrument. As I said, it works both with Android and iOS platforms. It not supports, but it works in real-time metrics. But it has their cons. It requires integration into the source code of your application to import some library to some small setup. Also, it requires some paid subscription to work. It has a trial period, but at the end you will still need to pay. We gave up with this instrument because of the first cons for us. It requires integration into the source code. We wanted some standalone solution without some integration. In other words, to communicate with the application from the point of view of a black box. So we continued to investigate and found Optim, another great tool or instrument. It's a desktop solution, at least in its personal license or in the free license for you. You need to install this instrument on macOS or to Windows, and then to connect your Android or iOS device to your laptop, to your server, for example, and to manually to start measurement. It has some UI, as you can see, and you need to find your device to choose the application you want to track, and then you can start measurement. On the right side, you can see some significant metrics which Optim can gather for you. It's CPU, memory, render, network, storage, and some power, and to graph them on this instrument. Okay, as a previous instrument, it has their cons and pros. Let's start from positive moments. It was also easy to start to work with this instrument. As you heard previously, it supports Android and iOS. It can be run on macOS, on Windows. Honestly, I didn't try on Linux, and do not remember about Linux anything. Does not require integration into the source code of your application. A lot of additional features, such as making some screenshots to recording a video of your screen while test is being run, some aggregation at the end, some assertion, providing you logs from your run, and visualization, yes. In a paid subscription, it provides you integration into CI/CD. But this tool requires quite expensive paid enterprise subscription. You can look at their site. In our personal opinion, it's a bit heavy solution, at least for us. And it at some point of working with this instrument, we noticed some inconsistency between metrics captured on macOS and Windows for the same native application, even for the same flow with the same speed and network speed, for example. So at this moment, we also gave up with app team and continued to investigate. A lot of our researchers came to some straightforward and uh, regular instruments for Android platforms, such as Android Studio, with the help of the profiling instrument, and Xcode, an instrument of Xcode for macOS platform with iOS support. But this instrument require some manual interaction with deep analysis of each run. Um, in other words, it's quite hard to work with these standard instruments in CI/CD, which was one of our requirements. So we started to write our own bicycle. It was PMetrium Native, and what it is really. PMetrium Native is a fully open source tool based on MIT license for measuring performance of native applications and the impact on the system. This instrument, fully written in PMetrium Tech by Mykola Panasiuk in cooperation with Pavlo Mykshak, my ex-colleague. And we even have got a logo, as you can see on the left side. As I said previously, it's a spoiler about PMetrium Native as an open source tool, and you can find it based on this URL or scanning this QR code. Later I will share this QR code once again. So continue. And before we go into details, and I would like to you to understand what is PMetrium Native and what it means. And first letters abbreviation PM, some of you might think about Parimatch, and they more or less will be right. But the original idea was the first letters of our names, Paulo and Mykola accordingly. And I guess you understand why. So moving to more interesting details, to logical diagram. At this screen we can see some gray rectangles, some classical components of functional test. You have some built application, functional tests, manual or automated, it doesn't matter, some workstation on which you work or run tests, and some Android or iOS devices connected to that workstation. When it comes to PMetrium Native, you have to add three components. One of them, PMetrium Native host itself, some time series database for storing data gathered by PMetrium Native, and data visualization instrument. And in our case, it was Grafana, and it is Grafana, connected to InfluxDB. So continue. Proceed to process diagram. And at this point, I need to be honest with you. PMetrium Native at the moment, version 1.0.0 supports only Android devices. iOS devices currently in a progress for PMetrium Native, and we almost have a good solution for it, but still coding some logic on a backend to work with iOS devices. So everything will be presented to you next will be related for a PMetrium Native working with Android device. iOS approaches will be quite similar, but I don't want to highlight difference at this moment because we still do not finalize them. So returning to the presentation about process diagram. Let's imagine that we have some functional test flow when you have three components functional test, workstation, and Android device. Functional test flow, shown in a blue rectangle, starts from the request from the workstation to begin the test. Then workstation need to communicate with Android device or with emulator. It can also be a case. Then test is been running or been run, and then test returns the result. Like the workstation in cooperation with device returns the result to functional test, and this is how does functional test flow looks like. When it comes to PMetrium native integration, you need only to add one step before and one step after that. Before, you need to start measurement. From a workstation, give a command to PMetrium native to start measurement with the help of RESTful API, for example, with a curl. And then PMetrium native communicates through workstation with Android device, run some logic, some scripts, and then hand over control to workstation to run a functional test. And it waits to application to start to measure automatically. After a test has been finished, you need to trigger stop measurement process for PMetrium native. Then PMetrium native uh, connects uh, connect connects once again to Android device, extract some metrics, parse them, and save in an appropriate format to time series database InfluxDB. And then we are able to visualize them on a Grafana dashboard. So that's it. And uh, everything I said on the previous slide is shown here. Just one step before curl to start endpoint with two obvious parameters, device and application, because you need to write a device IP address or a name, because PMetrium native can work in a parallel with a few devices. It means that you can measure performance of different applications at the same time. But you need to distinguish these with the help of device and application. Then you just trigger some test. It can be also manual. And after that, you say PMetrium native to stop measurement, only with one obvious parameters. By the way, start endpoint supports another parameters, and everything you need you can find in the documentation about API. Next, on this slide, I would like you to show a real demo according in advance before the presentation, not to waste the time for setup. And before I click to play this GIF file, or a video, in this case it was a GIF, I would like to present components which you are going to see on the screen. You can see three terminals. First one is just to communicate with PMetrium host with the help of a curl. Second terminal, I will show you here information on the device, which device we have, then we will connect to the device. On this terminal, which is going to be communicated first, I'm going to start PMetrium native host for communication with curl or with you, in other words. And on this screen, you can see my real device connected to my laptop. So let's start. I'm looking at a directory for PMetrium native host. I start this host. It has been started on this port. Then I move to this terminal to show that I have some devices connected. I have an IP address with Wi-Fi connected with ADB. So I connected to device terminal, then moving to SD card matrix folder and starting communication. It's not obvious steps on a second terminal. Then I communicating with my native application. I'm trying to show you that real-time metrics are being saved to txt file and they are changing with the time. Okay, and after that I'm finishing my test, proceeding to some event, for example, in our application, and to trigger stop measurement process. Everything is being logged, and I'm going to give you some details about how does it work in a few slides. Here we can see visualization on a Grafana dashboard for Android. We see different metrics, and we are going to discuss them on the next slide. Let's consider some examples I have for you. Just a brief introduction into this dashboard and metrics. For Android, currently we support CPU, CPU total, application, some RAM statistics for the system, like horizontal line, some total RAM used, application statistic, and so on. Network metrics, battery usage in milliampere hours, some frames. As you can see, rendered frames, it's a kind of metrics represented by total frames, not FPS, but total. Junkie frames, and a lot of these metrics are taken based on some Android platform based on dump-sys commands and another commands as well, and some application events. We'll discuss them a bit later, but at this moment I would like to point your attention to that how does PMetrium Native works from run to run. I did a run one by one, 5 times, and as you can see, almost the same results on each run. I did the same flow with the same application, quite on a quite limited window of time, and only some differences we can see on a battery chart. It's in my opinion it's okay because there can be also some differences from one run to run. It's quite common situation in performance measurement processes. Another good way would be to run few measurements in a row and then aggregate some metrics and take some medians, aggregate some average, some percentiles, as for example SiteSpeed IO instrument do. It's also quite good instrument for client-side performance testing, and then they provide such kind of functionality. I still thinking on how to implement this on PMetrium Native. Okay, another example. My testing phone has two display settings for refresh rates. One of them 60 gears and another 90 gears. I did 2 runs for both modes, and as you can see, 4 frames chart. First run around 200 rendered frames, and last runs quite significantly more rendered frames have on the chart. It represents, or it means that PMetrium Native catched that difference of display settings, and we can see the results on our dashboard. So a bit more advanced information for you. How does it work under the hood? The easiest way would be to start from the login on debug or information level for you to understand what is going on, and then we will see some more deeper details. So as you can see, after triggering a measurement process, PMetrium native host gets some HTTP request to start measurement with two obvious parameters, device and application. Then it builds a testing context or device context in my terminology. Um, it takes some default settings or override some settings which have been passed to start endpoint, because we passed only two parameters, but PMetrium Native supports another parameters as well. And we built a full device context, getting some information about device automatically, Android version as well, and then we pass that parameters to our main script, which is being run on Android device. As you can see in this red rectangle, some parameters passed to the script. And after that, we wait for the application to start. Once I tap on a native application on the screen of a mobile device, PMetrium Native knows the speed of that process and start measurements. Sometimes I do some activities with native application, and PMetrium Native tracks that metrics. Once I triggered a process of stopping measurement, PMetrium Native gets a device name to know which measurement to stop, and then we trying to extract some application events. I still remember to speak about them in a few moments after this. Then we need to take care of everything we just created or started on the Android device. You can see how much speeds do we have. We need to kill them or try to terminate, to exit from the script and extract and parse matrix. You can see on the logs. And after this process, the full life cycle of measurement has been stopped. So, about events, yes, as I said previously, I need to give you more details about events. One of our main requirements was that we do not want some integration into the source code of the application in order to measure performance of that application. But sometimes you really need to know some precise moments of what is happening with your application under the hood. Classical approach is to log some event or some to create some log in your application to track what is going on with it, and to save, of course, a timestamp. We used that approach as well. We just need to create a simple log in Android. For Android, it's logcat. For iOS, it can be a bit different. We still do not didn't finalize it, but are in a process with this. But still, for Android, you need to create a log in a logcat with performance testing tag and some human-readable description, some application side event with a timestamp in a Unix format. And based on it, we will read all the logs, parse them, and we'll try to save them and visualize. And on this screen, you can see the results. With the help of Grafana and annotations, we can toggle events to show with a blue vertical lines. In terminology of Grafana, it's annotations. And just to show some details about one event, for example, we hover a mouse on it and can read some details. Code boot application has finished loading at to know a time when it has happened, and to get some additional information, it's like Grafana uh, super skills here. And these two panels, last application events, in case you have some another runs on a time filter, and another representation of such information events on a timeline. You can see details and description of these events and the duration of each event from starting from the first one. Like the event has been successfully showed at on the 9th second. And to search this event on a timeline. And as I said, this requires integration into your source code, but still it's not obvious. You have a choice here. Okay, let's take a look at some realization of such logic. And for Android, we are using some shell or bash scripting. I'm decided to show you a shell version, and on this screen you can see a first script from what everything has been started. From start a SHA script, we need to do some preparation in order to measure performance, create some directory, to move some binaries files, for example, nettalks and busybox, to clean up some previous runs in case they didn't remove it on the previous run. And at the end, we need to trigger a script inside of the phone. On the previous step, we transferred this script, and at the end, we need to trigger and run it. And this phone matrix SHA script is a heart of our Android approach in PMetrium Native. It's quite complicated script, shell script. And the beginning of this script, almost the beginning, you can see on this screen or on this slide. And let's look how does work CPU usage statistic for the whole system. In this case, we check if we need to track this metric. If yes, then we continue. We are using here a top command with some additional parameters, then parse some information in a good format for us to parse later. And format is, as you can see, we are taking based on a shell pipes with the help of awk command, and save them in some txt file. Now, important to highlight that these files are being parsing only at the end of the test, not in real time. Of course, you can do that, but it will have some bad impact on the system at a time of extracting and parsing while your test in a progress. So we decided only to do that at the end. And the end of the script, as I said, it's quite long and complicated. It's the way, for example, how we take care about processes we created, and we need to kill them. And at the end, exit from the script. In case everything okay, then success. Good news for you is that we prepared everything in advance for you. I mean, some infrastructure related to PMetrium Native, as PMetrium Native, it's an instrument, but with cooperation with InfluxDB and Grafana, it creates for you some framework. InfluxDB for storing metrics, and Grafana for visualization, and maybe some of you noticed chronograph. It's a web tool for managing InfluxDB in case you need to change some settings. And everything is done in advance for you. So you don't need to create some Grafana dashboard, to create some databases. Everything is done based on scripting. And some interesting details that you, for example, have for InfluxDB already created user with admin login and password admin. The same for Grafana. Please pay attention to it while you are going to use it. Pros and cons of PMetrium Native. It would be dishonest to not remember about pros and cons of our instrument in comparison with what we already have on the market. So let's start from pros. Um, in in my or in our opinion, it's easy to start to work with PMetrium Native. Maybe some of you have worked with Appium, for example, an automation framework for native application and mobile devices. It's quite similar approach we use for PMetrium Native to hide the complicated logic behind RESTful API for you. Then another pros is to ability to work with PMetrium Native like a standalone service and communicate with the help of RESTful API, as I said before. It does not require integration into the source code of your application. I know that I said for events you need to do that, but in general it's not obvious. At the moment it supports Android devices. Later in a second version it will be added an iOS platform as well. We already created an ecosystem for you, InfluxDB plus Grafana. It's easy to integrate this framework to CI/CD, the same as for Appium, for example. And another big advantage, in my opinion, it's an fully open source software based on MIT license. But at the same time, we also have cons. It's trade-in at this moment. We support Android, one more time. PMetrium Native is a young tool, so bugs may happen. We hope not, but still it may happen because everything is quite new and need to pass some time to find issues in case they are. A phone matrix SHA in case of Android platform requires some system resources as well at the moment of tracking performance. In our in our cases, it was about from 10 to 16%. Quite more than we would like to, quite more, yeah, than we would like to have, but still. We plan to optimize these usage resources later in within updates. So where to move next for PMetrium Native? Spoiler for PMetrium Native version YNO version 2nd. Add iOS support. Add new metrics for Android platform, as we can add as more as we want, but we started from the most significant ones. We would like to get rid of the required root for networks matrix. I forgot to mention that network matrix for application requires root at the moment, as we at that time didn't find a solution to get matrix without root in a human readable format in a reliable way. So I think just a few people will be satisfied to work with rooted device, but we understand that it's not common practice, so our improvements will be later, and we have found a solution to get rid of root. Improvements for Grafana dashboard. We started from the quite straightforward Grafana dashboard, but we know how to improve it, even for Android, how to add some interaction, and you just need to wait, or you may contribute in case if you want to help us. And roadmap, it's not decided when we will be able to start work on that, but I hope in the nearest future. At the session support, as I mentioned, in case with UpTeam, they provide you an ability at least to get aggregated metrics, some base statistic, and we plan to add the same or even better to PMetrium Native. Improve the performance of phone metrics as SHA script. Its phone metrics script is quite good in our opinion, but still there are different ways how to optimize it. And of course, bug fixes in case of any. And ongoing process documentation updates. So once again, QR code to our instrument. Feel free to make some forks, to read and to comment some documentation on a GitHub repository. Contributors are welcome as well, and hoping you will enjoy our instrument. At this moment, that's all. Thank you for your attention a lot, and waiting for your questions.